now we've got 28. So this problem, not as difficult as the others, but really just a matter of converting all the units, okay? So they give you PV equals nRT. You can use that on almost all the chemistry questions. They give you that 1 atmosphere is equal to 101.3 kilopascals. This is a pressure. Atmospheres are pressure, kilopascals pressure. They say 25 degrees C is equal to 298. We know that anything in degrees C plus 273 will give you Kelvin temperatures. R is your ideal gas constant, and here they give it to you in liters per atmosphere divided by Kelvin times moles. Okay, that's what that K to the -1, mole to the -1. That means they're in the bottom. 50-liter cylinder of dry air. Dry air has a molecular weight of 28.8 grams per mole. Is filled to 16,000 kilopascals at 0 degrees C. What is the mass of dry air in this cylinder? So what we will end up doing is we're going to take all this information they gave us about volume, pressure, temperature, and we're going to use that with PV equals nRT to find the moles of dry air in the cylinder. And then once we know the moles of dry air in the cylinder, we can use the molecular weight to figure out how many grams are in the cylinder. Okay? So, let's start. 26 up here. Okay, so they gave us that PV equals nRT. Then they gave us that P is equal to 16,000 kPa. Volume is equal to 50 liters. Temperature is equal to, not 25, 0 degrees C. And R is equal to 0.08205 liters atmospheres per Kelvin mole. Okay, so in kilopascals, we need it in atmospheres. In degrees C, we need it in Kelvin. So start with temperature first. Temperature is equal to 0 degrees C plus 273 gives us 273 degrees Kelvin. Okay. Pressure is equal to 16,000 kPa. And then remember they gave us that 101.3 kilopascals per atmosphere, right? So pascals, we want the pascals on the bottom, so we're going to multiply by 1 divided by 101 kPa, and this is 1 atm, atmosphere up top. So the kPa's will cancel, and that will give us 157.95 atm, okay? 157 atmospheres. Now, all we gotta do, we're gonna plug everything into PV equals nRT. So we got 157.95 atm times 50 liters is equal to, we don't know N, that's what we want. R is going to be 0.08205 liters atmospheres Kelvin mole times, running out of room, 273 Kelvin, right? And I should have started a little bit further, but we got atmospheres on top on both sides, so that means we can cancel them. We got liters on top on both sides, we can cancel them. There's a K over here and a K down here. Those will cancel. All that we have left is moles, right? So when we bring all of this over here and divide by it, which is what we're going to do, and then it'll be times a 1 over a mole right here, but this is really 1 divided by 1 over mole, so get rid of all that. It's just moles is equal to N, which is the unit of N, right? N is the moles. This is going to give us N is equal to 352.57 moles. Okay, last little part. All we got to do, they wanted us to find the weight of dry air in the cylinder, correct? So this needs to be in grams. We have that the molar weight of dry air is equal to 28.8 grams per mole. Okay? Moles on the bottom, moles up top. So all we gotta do is 352.57 moles times 28.8 grams per mole. Mole on the bottom, mole on the top, gone. And that gives us 10,154 grams. Okay? But our answers are in kilograms, so we got to get this grams to kilograms. They are 1,000 grams per kilogram. So we have kilograms on top because that's the units that we want. So we're going to get 10,154 times 1 kilogram per 1,000 grams. Grams will cancel, and that will give us 10.154 kilograms.